everyone. Thank you for joining us today for our TDT ABR webinar. My name is Jessica Falcone. I'm technical sales over at TDT. And just for a little background about myself, I have been at TDT for about 2 years now. I did my PhD in neural engineering at Georgia Tech. I had a primary focus in brain electrodes. I was studying the immune response and trying to improve chronic recording fidelity in animal models. And then I went on to do a postdoc at the Feinstein Institute for Medical Research in their bioelectronic medicine group, working with chronic electrodes for the vagus nerve and trying to interface them in a chronic mouse model. And then I went on to join TDT, and so now here I am on the technical sales team. And Jen, before I get started with the webinar, I just want to give a brief background about TDT. We've been in the auditory field for 30 plus years, and we also are involved, our company in general makes research systems for neuroscientists, so not just for auditory, we also make systems for electrophysiology, fiber photometry, and most recently, behavior. So now, without further ado, I think we can go on and get started. So before we get started, I will go on and give an interview or an introduction to ABRs, explain what they are, why they are a useful tool for neuroscientists. Then we'll go through an overview of the TDT hardware system, particularly our processor, amplifier, and speakers for ABRs. Next, we'll take a look at the BioSig RZ software for controlling the entire system, specifically sound generation and signal acquisition. And we'll also look at our speaker calibration capabilities. Last, I will give an overview of additional equipment that is needed to complete the system. And then we will conclude the presentation. Also, there is a chat function and a Q&A function, so please feel free as the presentation is going on to enter in your questions, and we will address them at the end of the presentation. ABRs, or auditory brain responses, are an evoked potential that's in a response to an auditory stimulation. Typical auditory stimulations are clicks or tones. And over here I have an example of an ABR that was recorded in a mouse. And so you'll notice in this image that there are 5 distinctive peaks that have been labeled. And each one of these peaks is going to correspond to a different brain region. So ABR is interesting in that it's a summation of different neural signals across different brain regions. And here I have an example of the different parts of the auditory circuit and how they correspond to each peak in the ABR waveform. Of particular interest is peak 1, which corresponds to the auditory nerve, and peak 4/5, which corresponds to the lateral lemniscus and inferior colliculus. Now, typically ABRs are used to detect an auditory threshold, and this can be done by reducing the intensity of the auditory presentation. And when the intensity is reduced, we'll notice a change in the shape of the ABR waveform. Of particular note, you'll see changes in latency, which I've illustrated here for peak 1. So you'll see that the peak of the maximum peak has started to shift in time as the intensity decreases. And there are also can be changes in amplitude, which I've illustrated here with peak 2. In this case, the amplitude is decreasing as the intensity is decreasing. So all of these features can be analyzed to draw meaning about the changes that are occurring in neural processing. Next, I have an example of ABR that was collected from a paper. So here, this is a noise exposure experiment, and a click ABR is presented to the animal. So here you can see the ABRs being collected, and it looks like the ABR threshold is around 30 dB in this wild type pre-exposure animal. And then next, the animal will be exposed to a loud noise, in this case 85 dB, and the ABR was then collected again, and you can see that there's been a shift in the ABR threshold. It's now occurring around 45 dB. So ABRs are a very useful tool for an array of areas in neuroscience research. They're particularly useful if you're doing any studies that involve drug effects on the cochlea, noise damage, hearing recovery, and age-related hearing loss. So what do you need to start collecting your ABRs? There's two main components. There's sound generation and data acquisition. For sound generation, you're going to need a processor that can generate waveforms and generate unique waveforms that have different intensities, different frequencies, and also present these waveforms at precise interstimulus intervals. You'll also need a speaker that is easy to calibrate. Next, on the data acquisition side, you will want an amplifier that has a low noise floor so it can collect these low amplitude ABRs robustly. And then you'll also want a processor, again, that can synchronize the data acquisition with the sound generation. The processor will also need to be able to average multiple trials and allow you to view your data online. And this is where the TDT system comes into play. So I'll now walk you through all the hardware components of the TDT setup. Specifically, we will be focusing on our RZ6 processor, our speakers, and the Medusa 4Z amplifier. The RZ6 processor is the brains of the operation. It will be controlling your sound generation and your data acquisition. And it also is a high frequency auditory processor. It has a max sample rate of 200 kilohertz, meaning that it can present an auditory stimulation of about up to 84 kilohertz. So inside the RZ6, we have two analog outputs, and this is going to include built-in speaker drivers, which will connect to TDT's magnetic and electrostatic speakers. We also have a headphone driver if you're doing human work. And then we also have speaker attenuation, both programmable and manual. And then finally, there's an onboard speaker for monitoring your signals during the experiment. We then have two analog inputs, and this includes a microphone amplifier, which will be useful during speaker calibration. And we also have our amplifier connection. So now I'm going to talk about our speaker options. At TDT, we have two types, our magnetic speakers, our MF1s, and our electrostatic speakers. The MF1s are very good for rodent research. They have a flat frequency response, or they have a flat response from 1 to 65 kilohertz at 90 dB. And then our electrostatic speakers are a good option for ultrasonic stimulation. So you'll see their frequency response is on the higher end, 4 to 110 kilohertz. And then both of these speakers are easy to calibrate. Next, I'll talk to you about our Medusa 4Z amplifier for ABRs. You'll notice the main takeaway for this amplifier is that it has a low noise floor. So ABRs are a low amplitude signal, and this low noise floor is important for being able to robustly collect these signals. The Medusa amplifier also has a large input range, so it's versatile and can collect other signals other than ABRs. We have onboard impedance testing for your electrodes, which is easy to perform. And then the amplifier is also battery operated and optically isolated. So this means you can take the amplifier and place it inside the sound chamber next to your subject and not have to worry about injecting electrical noise into your ABR recordings. Before I complete the ABR setup, I just want to touch briefly on subject preparation. In this example, I am using a rodent. So if you are using an animal, you will need to perform anesthesia. We do have more information on different options in our ABR guide online. And then next you will have to insert electrodes, in this case subcutaneous needle electrodes. And the main things to take away here is that you will have a recording channel, which is the red channel, your reference channel, which is black here, and your ground channel, which is green in this example. The placement of the reference and ground can depend, and we go into different options in more detail in our ABR guide online. So now we're going to put the whole system together. We're going to start with the RZ6, which is again the brains of the operation. It will connect to our speaker, which will produce our auditory stimulation to the animal. The animal will have be connected to the electrodes, which will then connect to the Medusa 4Z amplifier, and that will connect back to the RZ6. So in summary, a big takeaway from our hardware setup is synchronization. We have one processor that is performing both your sound generation and data acquisition, and we've provided the additional peripherals to perform both of these functions. So for sound generation, we have broadband speakers that are easy to calibrate, and for data acquisition, we have a low noise amplifier. Next, we're going to need software to record ABRs and control this whole hardware setup. So this is where BioSig RZ comes into play. It has an easy to use interface that gives you direct control to the RZ6, and you're going to be able to perform your sound generation and data acquisition all within this one software platform. So within BioSig, we offer preset templates. The first is for clicks. So clicks are useful if you just need to confirm that an animal can hear Clicks have a broad frequency spread, which you can see over here in this frequency plot of a click. Next, we have a template for tones. And tones are useful if you need to generate tuning curves and identify frequency thresholds for your subjects. Within BioSig, you have access to customizing your parameter set. So you can start off with either one of these tones or click templates, and then you can go through and modify an array of parameters, including frequency, intensity, gate time / gate type, duration, and more. So you can go and adjust the step size, the range, what have you, in order to perform your experiment. Then on top of that, you can modify your stimulus schedule. So you have the option to do this at runtime or do a predetermined schedule ahead of time. And this is particularly useful if you need to configure different schedules for different cohorts of animals. So say you're testing deafened versus wild type animals or old versus young, you can have separate schedules that will adhere to those different model types. So now we're going to take a look at ABR recording in real time in BioSig. So just to walk you through what we're looking at, this top window here, you can see is our real-time data viewing. We can see the running average as it's being collected for our parameter set. And then over here, we can see the parameters of our signal, so the frequency and the intensity level in this case. And then you'll also notice below that we have a history plot that is being populated as the ABRs are being collected. And then again, over here on the left, there is the parameter set with pertinent information such as frequency and intensity. So a major takeaway of BioSig and the TDT system in general is that it is able to synchronize the data acquisition with sound generation. So your sound generation is happening at precise interstimulus intervals. In this case, it's 22 presentations a second, and your data acquisition is happening in a 10 millisecond window. So there's very tight timing that needs to occur in order to generate and record these ABRs, and the TDT system is able to do that. And then you'll also notice that the BioSig is able to average your signals in real time. So if you look at the top window, you can see the signal will be gaining resolution as more trials are added to the average. And the reason that this is important is we perform averages in ABRs to improve the signal to noise ratio. And then finally, you'll want to be able to view your data online. And a good example of this is in this, this setup, I have selected, here we go, the first ABR that was recorded. And now you see that it is overlaid in the real-time data viewing window. And so now you have access to not only viewing your data as it's being collected, but also directly comparing it to another ABR waveform. And then along those lines, we have history plots within BioSig. And so you can go and scroll through and start to identify your ABR thresholds while the data is being collected. And if you need a closer look, you can go and select two waveforms, and we can do an expanded window of those waveforms. In this case, I selected a 90 dB waveform in white and a 30 dB waveform in green. We'll expand the view, we'll overlay them, and so you can start to analyze where your ABR threshold is occurring. Finally, we do have data export for offline analysis from BioSig. You can export out into CSV, ASCII, or MATLAB and perform additional offline analysis in whatever platform is easiest for you. Next, I want to talk to you about speaker calibration. This is required for ABRs, and the reason is if your speakers are not calibrated, you cannot be confident in the intensity the speaker is delivering. So what does a speaker calibration do? It's going to ensure that your auditory stimulation has the same intensity across a frequency range. So this is also known as a flat frequency response. And the big reason to focus and perform speaker calibration is it's going to give you consistency and repeatability during your ABR experiments. So I'll show you how we set up a speaker calibration using free field speakers. So first we're going to replace the subject with the microphone, and you'll want to position the microphone at the same distance and height of where your animal's ear would be. Next, we're going to connect the microphone up to the RZ6 via the analog input, and then we're going to switch on the microphone amplifier. And now we're going to go and run the calibration module on the BioSig RZ software. So here I have an example of tone calibration. And so the first line that we're looking at is the frequency response in blue. The yellow line is the harmonic distortion, and then the red line is the correction curve. So now I'm going to go and run the tone calibration so you'll hear the frequency sweep as it's being generated. And so here you can see the correction curve being generated in real time. So now we can save that correction curve file and run it again in the tone calibration. And if the correction curve is accurate, we should have a flat frequency response. So again, we can see the frequency. So actually, I'll just run the calibration again. So you can see the frequency response in blue being generated. It is pretty flat at 90 dB. And so this would suggest that the calibration file is accurate, and we can use this for our ABR experiments. Next, we do have a final test that you can perform. You can load up your calibration file in BioSig before performing your ABR. And then we have this tool that will let you confirm that your intensities are where you expect them to be. You can enter in your frequency in your volt RMS level and turn on your analog output, and the intensity will be measured for you. So in conclusion, for the BioSig RZ software, the main takeaway is that this is an easy to use software for ABR recordings. It's a single interface for presenting your sound generation and your data acquisition, and we also have built-in speaker calibration. As we start to wrap up the system, there are some additional items that are needed to complete the setup. Typically included with the TDT quote will be, these are third-party items, so that will include a calibrated microphone shown at the top here, and then electrodes. So we offer needle electrodes for animal work, and we also offer surface electrodes for human work. And then some other items that will need to be purchased separately are heating pads. We offer more information in our ABR guide online for different options to choose from. And you will also need a sound attenuation chamber. So a sound attenuation chamber is important as it's going to reduce a good amount of noise that occurs during ABRs. So your primary noises during ABRs are going to be acoustic, electrical, mechanical, and biological. And the sound chamber is going to take care of those first two, acoustic and electrical, and just prevent a quiet environment for collecting your data. And then here are some specs to look out for when you are selecting a sound attenuation chamber. Main thing is you'll want to get a metal chamber that is double layered. This is going to provide acoustic isolation. And then you'll also want RF shielding. This will be electrical isolation. And then you'll also want to have acoustic foam in the interior. And here are some brands that we recommend for our sound attenuation chambers. So as we wrap up, I just want to mention that TDT does have a tech support team. I've provided their contact info. You can reach out via email, support@tdt.com. You can call us, or we can hop online with you and do a live screen sharing session. They're available to help you with setting up your equipment, debugging software, any general troubleshooting, or if you just have a new experiment that you want to test out, they are there to help you. And we also have a handy ABR guide that's available online. I've shown a screenshot of that. This is a fantastic walkthrough for general setup and troubleshooting for both the hardware and the software. So definitely a good resource to check out. And then finally, TDT has a 5-year hardware warranty. So what else can you do with your RZ6 system? I want to emphasize that it's not just for rodents. I know this presentation has been rodent heavy, but we have several researchers performing ABRs in other models such as fish, humans, non-human primates, and other small mammals. And then the RZ6 is not just for ABRs. You can also perform DPOAEs. We'll have another webinar in the future on that modality. You can also perform noise exposure experiments, mismatch negativity, pair it up with our EFIS for auditory electrophysiology. A lot of different options are available. So in conclusion, why do you want to choose TDT for your ABRs? First off, TDT has been in the auditory business for 30+ years. We have over 6,000 publications with people using our hardware to collect ABRs. And as you've hopefully seen through this presentation, we offer an all-in-one solution. We have optimized hardware for ABRs, including our RZ6 processor, our low noise Medusa 4Z amplifier in our broadband speakers. We have an easy to use BioSig RZ software, which will give you access to your sound generation and your data acquisition. And then we have built-in software for speaker calibration. And then finally, we offer tech support for supporting your experiments. So with that, I want to thank you very much for your attention. Again, my name is Jessica Falcone over on the sales team. I've presented the list of the other members of the sales team. I'm sure you've interacted with a few of them. And I've also, our email is sales@tdt.com. And then I've also provided the tech support team, their email support@tdt.com. And I do want to highlight Chris Walters, our applications engineer on the tech support team. He's actually going to be hopping online with me now. We'll open up for the Q&A session, and we'll be ready to take your questions. So with that, I want to thank you for your attention, and if you have any questions, we're here to answer them. Okay. So I guess it looks like the first question we have from Torsten Ron is there hardware and or filtering options? And that's a little bit of a broad question, so I guess we can kind of tackle it however we want.
Right, so it looks like Victor already responded to that in the Q&A.
Okay.
But yes, to answer your question, there are both hardware and software filtering options. The software filtering options are available real time. So if you're running an ABR and you see that you have a higher than expected noise floor, whatever the situation might be, you can actually change your filters to try to accommodate whatever sort of noise is happening in the environment. The hardware filters with the Medusa 4Z, those are selectable right on the hardware, and those are changeable as well. Generally, you would set those before you begin an experiment. If you decide you want to change those, a couple of button presses right on the Medusa 4Z will accomplish that.
Okay. Let's see. So where do we want to start? Do we want to skip over the questions that Victor has already answered then, or do we just want to run through them?
I think probably
some
so.
of them are a little more detailed and not necessarily for general consumption. So why don't you go to, I think Lars's question is a good one.
Okay. What are the attenuation units? For example, 5 dB.
So by default, the examples that we give will run an experiment 90 dB, 80 dB, 70 dB, and so forth, down to 20 dB. You can change those, again, either at runtime or ahead of time, and commonly people will do 10 dB steps away from the threshold, so 90, 80, 70 dB when you expect a good, strong response, and then we'll step down to 5 dB steps nearer threshold to get you a more accurate representation. But what you do as far as 5 dB steps, 10 dB steps, or something else if you prefer, that's completely up to the user. You can program your stimulus file, what we call a SIG file. You can program that to step at whatever interval you prefer.
And I think the question above, actually no. So the next one is, with BioSig RZ, would you be able to present stimuli other than clicks and tones, for example, vocalizations?
Absolutely. We have lots of other examples. The reason that Jessica focused mostly on clicks and tones in her presentation is that's what most people do. However, if you have a vocalization that you want to present, whether it's a subject vocalization or various sounds, ma, ba, da, things of that sort, you can present those things. We can load them up in a buffer and present them just the same as a click or a tone. We can also do various kinds of noise. We can do frequency sweeps. Those are all possible.
Okay. And then a quick question here. I saw Victor had already answered it, but asked, are all raw data stored or only averages?
That's up to the user. So with our current software that is available for download on our website, if you guys haven't updated recently, you guys can get access to this functionality if you'd like it. Traditionally, BioSig has given a number of averages, let's say 512 typically, but you can adjust that, and then it would give one averaged response. Here in the last version that we released, we let you save individual traces. So in addition to that averaged response, you also get each of the responses that comprise that average.
And then we have a question about calibration. They're asking, first, so for instance, if we test 20 animals, do we have to calibrate all animals, or is one calibration enough for the test? And I think this is probably going to go into whether or not you're doing free field versus closed field, would be my guess.
Yeah, I mean, in a free field environment, generally speaking, most people get a couple of days out of a calibration, but you can check the calibration as often as you want. If there's been any change to the environment, absolutely check the calibration. If you have any reason to suspect that something is not correct, check the calibration. Jessica went through that in her PowerPoint presentation where she had the needle that was going back and forth. And if you want to verify that it's accurate, hooking up the microphone takes only a few moments. Check your calibration, and if it's good, then you move on and keep using the same calibration. Each environment is different. And so, you'll have to test it, get a feel for your environment, and then once you know what works for you, you can use that going forward.
All right, very good. So the next question along calibration is it possible to calibrate with an external speaker, and how would this look like?
I'm not sure I understand what an
so
external.
I think what Lars is describing is what we really are doing anyhow, which is that if you didn't want to purchase a TDT speaker and you wanted to calibrate your own speaker, then yes,
like
you can certainly plug in our system and configure it so that you can calibrate whatever speakers you have. It's just a matter of making sure that you have a good calibrated microphone. And that you have fixed distances, and you make sure that all of the other configurations are correct, and you can use any speaker, either a TDT one or an external one that you've purchased yourself for calibration.
Let's see. So
somebody asked a question about phase, and so phase normally is not a issue with the system. The main reason that we use phase is so that it can alternate the output, and this minimizes your stimulus artifact. So it's a way of reducing the stimulus artifact. It's also a way of testing whether you have an ABR. ABRs are not affected by the phase of your stimulus presentation. So if there is a phase effect, then you'll find out pretty quickly that you don't have an ABR. It's just an artifact of your signal.
Okay, we have a question about, I have an older RX6 Medusa ED1 PA5 system. Is this compatible with your new software? So just to answer that, we do have a previous version, BioSig RP, that will run that, and I guess I'll let Chris take over for next steps.
Right. So there are some differences in the software. Some of the calibration tools that were discussed today are not the same between BioSig RP, the older version, and BioSig RZ. So no, unfortunately, the answer is, it's not going to, BioSig RZ is not going to work with your RX6s, but there's still a lot of great research being done with BioSig RP. We still do support it. I still do support it. And so I can help you guys out with any questions that you might have. If you decide that it's worth talking to Jessica about an upgrade, we do have a trade-in program. So she would be happy to work with you on getting, the latest and greatest hardware and software if that's something you're interested in.
All right. So the next question is, how how do you measure the ABR wave 1 amplitude?
When you take a look at the signals themselves, we can click on a signal, we can bring it up into focus in BioSig, and we have a function called cursors. And so you can place a cursor at any point of interest, whether that's peak 1 or any of the peaks, and you can get an exact measurement of the amplitude of a peak. The other thing that you can do, and Jessica talked about this previously, most people will export the data into some other tool to be able to use it for some sort of presentation or paper or something like that. When you do that, you can plot your data and you can read maximum and minimum values off of the export if you prefer to do it that way. So 2 different options depending on your preference.
Okay, very good. Thank you for that. I think we've hit the end of our questions list. So it looks like that's about it. So if there aren't any other questions, we'll wrap up the presentation then. So I just want to thank you all very much for taking the time to listen to our talk on ABRs. Again, if you have any questions, sales support, feel free to reach out, either sales@tdt.com or support@tdt.com, and we're happy to answer your questions. So thank you very much, and have a good morning, evening, late evening, wherever you're located in the world. Thank you.